Hi, so today we are going to start section 1.6, which is on complex numbers. So a complex number is a number of the form a plus ib, where a is our real component and ib is our imaginary one. So a and b are real numbers, and I is defined as the square root of -1. So from here, we have some examples of complex numbers. So we have 3i, where in this case, our real component a is 0, and so we're just looking at b equal 3. And we also have 2 plus 6i, where 2 is our a, our real component, and 6 is b, our imaginary coefficient. We can also have numbers a little more funky, like 4 plus the square root of 3i. So we can also have things that are not integers, like square root of 3. So then there are some operations on complex numbers. So with complex numbers, we're able to add, subtract, multiply, and divide, all of the normal things we do with our other numbers. It's just a little bit different. So we can add, subtract, multiply, and divide with complex numbers. So for an example, if we start with adding, if we look at 6 plus 3i plus 2 minus I, well, we can just add, get rid of our parentheses. So we have 6 plus 3i plus 2 minus I. And now we'll look at things with and without i's. So then we will get 6 plus 2, which is 8. And we'll get 3 minus 1, so we get plus 2i. And then subtracting is very similar, except we'll have a minus sign here, and we'll just distribute that through. So then we can also look at an example of multiplying complex numbers. So we take minus 9 plus 6i times 7 plus 2i. So it's going to be very similar to FOILing when you're having algebraic terms. So we'll look at 9 times 7 and 9 times 2i, and then 6i times 7 and 6i times 2i. So first we get minus 9 times 7 plus minus 9 times 2i. And then we can look at multiplying out. So then we have a minus 63 minus 18i plus a 42i. And then here we get a 12i squared. And now what we want to remember is that I equals the square root of -1. So I squared equals the square root of that should be a -1 squared, which then just equals -1. So if we reevaluate, we have -63 minus 18i plus 42i minus 12. So then if we add everything together, we will get a minus 75 plus a 24i. And now if we look at how to divide complex numbers, so we take 3 plus 4i and we divide it by 2 minus I. Well, our first step is we want to look at the complex conjugate. And what this is we look at our complex number, a plus bi, and we write it as a minus bi. So you just make negative your imaginary term here. Instead of adding it, you subtract it. So for us, our denominator, we have 2 minus I. So the complex conjugate becomes 2 plus I. So if we go back to our original fraction, which was 3 plus 4i over 2 minus I, and then we multiply by 1, but in a special way where we have it as 2 plus I over 2 plus I. And from here, we can write it as one fraction. We can multiply them together as 3 plus 4i times 2 plus I all over 2 minus I and 2 plus I. So now we're going to expand the denominator first. So we'll just keep the 3 plus 4i times 2 plus I until we're ready to expand that. And if we look at expanding it, we will get a 4 minus 2i plus 2i minus I squared. And if we see the minus 2i and the plus 2i will cancel. So then we get a 3 plus 4i times 2 plus I. But then here, remember, we have this minus I squared, where I squared is negative 1. So then we're going to get a 4 minus 1. So that becomes 3 plus 4i times 2 plus I all over 5. Now we're going to expand the numerator. So we get a 6 plus 3i plus 8i plus 4i squared all over our 5 still. So then if we combine, or first if we look at our I squared term again, that's going to become a negative 1. So we're going to get a 6 plus, and we can combine our 3i and our 8i to an 11i. And then rewrite this as minus 4 all over 5. Then we get 6 minus 4 is 2 plus 11i all over 5. And if we distribute the over 5 to each part, we get 2/5 plus 11/5 I. And that is our final answer. So those are some ways that we can add, subtract, multiply, and divide with complex numbers. All right, thank you so much.